cluster of computers in a Hadoop cluster functions as a single large-scale storage unit, and the Hadoop software is handling all this management of how we put the files on all the many different machines in the cluster and bring them back. You should also know that Hadoop is originally named for Doug Cutting's child's toy. Hadoop the elephant, just a name that his child had given this toy, invented, and so it's not an acronym for something else. It doesn't have a technological meaning, but it is represented by a yellow elephant because Hadoop, the original Hadoop, was a yellow elephant. And you can read more about that on this site that's linked. The complete documentation for many of the things I'm going to talk about are Apache projects, and if you go to the apache.org Foundation site, you will get what's really the best source of documentation. It's good to get an introduction to, what is this all about somewhere else. You may find some introductory guides that will walk you through. But again, these are rapidly changing technologies. You might have new versions coming out that make significant changes as they come out. The original websites are always going to be the most complete source of documentation. So once you get somewhat familiar with a particular piece of software, I'd recommend keeping in touch with that original source site. So Hadoop manages the Hadoop distributed file system. Again, the links in the presentation will take you into the real details. We're not going to go into that here. But the Hadoop distributed file system, HDFS, allows you to treat a cluster as one big hard drive. And we're going to just look real quick at the Hadoop architecture to give a feel for how this works. So in Hadoop there is a name node, which is kind of the controller or the master of the system, and there are slave nodes. So these are lots of different locations out in the computer cluster. You can think of each one of these 5 boxes in this image as a computer. And when I say save this big blob of data on a Hadoop cluster, the request goes to the name node. The name node chunks that blob into discrete parts, and it can put one part on each of the clusters in the node. And it also has a job tracker system. It needs to confirm that yes, it successfully wrote the data to the node, and it's done. If it encounters a failure, it has to have a way to reroute or retry the job. And there's a lot of that detail, which gets pretty complicated when you start talking about hundreds of machines, that the Hadoop software manages. So that's about as deep as we're going to go into Hadoop architecture. There is a lot in when you're actually administering a full-on Hadoop cluster and keeping everything performing well that we are not going to touch, and we're just going to stick with a very basic level here. But you should recognize that if what we're talking about here is the simple basic level, and to actually set up a giant Hadoop cluster, there's a lot of administration activity that goes on in that configuration, maintenance, big task. Okay, so the next topic that we're going to talk about is the Mapreduce paradigm, as it's often described. So we have our HDFS file system. We can put things on our Hadoop cluster. And again, we're talking about Hadoop here because it is the most common or dominant technology and associated group of programs that has evolved in this web big data space. There are other software and environments out there, but we're using Hadoop as the main example, which is also the most widely used and popular example. But on a Hadoop cluster, you want to not only store the data, you want to run analysis. After all, we're kind of coming at this from the data perspective. We want we want to search, we want to collect, we want to analyze the information that's on these clusters. And we do that with Mapreduce. So it's called Mapreduce because it has two major blocks of operations. So we map and we send a particular job out to the many different computers in the cluster. It returns a result from each computer in the cluster, and then we have to have a way to collect all those together, which is called the reduce component. Probably the most common way to write such a function in its native form is as a Java program. Although, as we'll see, there are many other ways to do a Mapreduce function. You can do it in other programming languages such as Python, but the programming approach requires expertise in programming, obviously, and also familiarity with the data itself. Okay, so we've been talking about it. Let's see what that means. Again, in the slides, we link to an image that describes that map, that illustrates the Mapreduce process. All right, so start on the left. We have a block of data. In this case, 3 lines of text: Dear Bear River, Car River, Dear Car Bear. We split that data, and essentially the split means we're sending each piece of this out to a cluster. Let's imagine this is 3 computers where we've stored Dear Bear River on one computer, Car River on the second computer, and Dear Car Bear on the third computer. All right, now we get, starting in the middle here, our Mapreduce section. So we map. We want to actually do a word count of our data. And so we send a function to each computer in the cluster and ask it, well, how many words do you have? On cluster 1, we have 1 deer, 1 bear, 1 river, and so on cluster 2 and on cluster 3. That's the map part. Now there's actually an intermediate step which they don't talk about in the name. That's the shuffle step. So we don't say map shuffle reduce, we say map reduce, but there is a shuffling. So the shuffling takes all the input. Our master node, again, is collecting this information back. So it knows deer, bear, and river are on cluster 1, and so then it sorts together all the occurrences of deer, all the occurrences of bear, all the occurrences of car. And then it's in a position to reduce them and actually count. So we add the bears together and get 2 bears, 3 cars, 2 deers, and then we can kind of concatenate that output into a summary. But so you see here the mapping occurs on each node of the cluster. This is the distributed computing part, and the reduction occurs at the master node. Now this is a very simple function. We can write much more complicated functions, but as long as they can be split into a map phase and a reduce phase, we should be able to find a way to do it on our cluster. So that looks nice and simple in the illustration. If we look at even the most basic example of a word count, this is the one provided as sort of the first step in a tutorial at the Hadoop documentation. This is what a Java program looks like that does a word count. And this may look simple to some Java programmers out there, I'm sure it does, but to someone who's not familiar with Java, like me, this looks reasonably long and complicated. So we are going to talk about ways to avoid the full-on programming approach to actually running analysis on our data. So that's coming up in the hands-on part. On the other hand, the programming approach is obviously more flexible. You can really get in and do whatever is possible to do with your data if you have the programming skills and if you know exactly how your data is structured. but that's a high barrier for some people. So on this slide, I've also linked 2 video intros. The short intro is a really nice video that will put this moving back and forth of data in the cluster in a nice context for you. I think that's a very good place to start. And the longer video is close to an hour and a half and talks about many of the elements in the Hadoop ecosystem that we're going to touch on in our upcoming videos, but you may want to take a look at that as a comparison, one big video. All right, so a little bit more about working with Hadoop, and this will be the last slide for this section. When we're working in the Hadoop ecosystem, every part has its own command line tools. When we talk about a Hadoop cluster, we have ways to get into the operating system and configure that cluster. When we want to work with putting and getting files, there are command line commands like Hadoop fs put to place something into the system that handles that, treats it just like you would a file on a single local PC, but sends it out to the distributed file system. So this is the work that Hadoop is doing for us, is letting us kind of get in and do things with some simple commands. If you're running a production system, you're going to have to do a lot of command line configuration to get it just the way you want for your own data. So we're going to take shortcuts in our illustrations by using some pre-built environments. And just, again, be aware, when you really do this, you want to customize it for your own environment. And that's going to be a bit more work, but will also have lasting value compared to what we're doing as demos today. So again, just to illustrate, some people build Hadoop clusters out of Raspberry Pis just for fun, or just to show that they can do it at a small scale. So this is a toy Hadoop cluster that can still store a little bit of data. A big Hadoop cluster can get quite large. This is actually one of the early famous pictures of the Yahoo Hadoop cluster, and Yahoo was one of the original developers, as we've said, of this technology. So hundreds and hundreds of servers all spinning with their own data. And again, as we've mentioned before, Google has dealt with this in their own way, somewhat more proprietary, but you can read a bit about it and learn about it. If you search on Google for a Google BigQuery, you'll see some of that information. If you search on Bing, you'll probably explode the internet if you search for Google BigQuery on Bing, but you can try that as well. All right, so that's the end of this part of the presentation. This is the last sort of slide-only part before we dive into hands-on work. So that's coming up in part 3. Part 3, we're going to use Amazon Web Services to spin up a Hadoop cluster.